Here's an important fact to bear in mind. This finite planet cannot expand to accommodate all our needs and desires. Our ravenous economic activity is rapidly depleting precious natural resources and straining the planet's ability to absorb our waste products. It appears we don't fully appreciate the fact that our primary wealth resides in nature. In this section, we'll look at some ways we are depleting essential natural resources faster than originally thought possible. As this slide illustrates with copper extraction, we've picked all the low-hanging fruit. In 1903, this boulder-sized nugget was found, just lying open on the ground. But today, tons of rock must be mined to extract 10% of copper ore. Like all creatures tend to do, we've used up the easy, high-quality resources first: soil, aquifers, old-growth forest, metals, minerals, coal, oil, natural gas, and some plant, animal, and fish species. The reality is that finding and extracting sufficient resources in the future will get increasingly harder, as this next chart graphically shows. In this chart, we're looking at the grade of copper ore, with the tons of rock mined shown on the left side vertical axis and the quality of ore grade on the horizontal axis at the bottom. At bottom left, the graph begins by showing that it takes 6 tons of rock mined to produce 1 pound of copper. As the graph moves left to right, it shows that more and more tonnage is needed, climaxing with an exponential curve that rises to show that it takes 160 tons of mined rock to extract 1 pound of low-quality ore-grade copper. In sum, we are increasingly challenged to find and extract high-quality grades in mining all finite resources. And just think of the diesel fuel used in moving those trucks many miles, from the bottom of the pit to the processing plant. And here's a photo of a huge copper mine, illustrating how hard we're working now as we progress along the depletion curve. Originally a mountain, this mined cavity in Utah is 2.5 miles across and 3/4 of a mile deep. Each of many mammoth-sized trucks handles 250 tons per load of rock that produces 0.02% of copper ore. It's estimated that if donkeys were used, each carrying 150 pounds, it would take 3,400 of them to haul 1 truckload. Now, on a positive side, maybe this gigantic hole could be used as a mass amphitheater or stadium, or perhaps for the Olympic Games. Marathon races from top to bottom and back might work well for cyclists and runners. The Alberta oil tar sands are among the largest deposits of this type in the world, covering an area the size of England. Mining the area is gradually destroying an old-growth boreal forest, home to numerous migrating creatures. About 2 tons of oil sands are required to produce 1 barrel of oil, which is approaching the non-profitable 1-to-1 ratio, a tipping point, when production is no longer viable. On another dark side, oil tar sands extraction generates more CO2 than all the cars in Canada combined, and every day, nearly 3 million gallons of toxic runoff pollute waterways. Minnesota is one state that depends on these oil sands for gasoline, approximately 6 of every 10 gallons used. In terms of tonnage, U.S. coal production can still increase. But in terms of energy, the only metric that really matters, U.S. coal production peaked in 1998. The shiny hard stuff, anthracite, which is used in coking coal for making steel, is nearly gone. Low-quality subbituminous and lignite coal have risen to replace the depleting bituminous grade. Internationally, to the extent reserves can be accurately estimated, several recent coal forecasts predict the peak energy content of coal will occur in the next 50 years, not the hundreds of years that we're often told. In the U.S. and globally, we use coal to generate over 40% of electricity. To service the energy needs of all 7 billion people, some mining companies are resorting to use this type of deforestation strategy. According to a 2005 environmental impact statement, mountaintop coal mining has buried and contaminated more than 2,000 miles of streams in Appalachia, and many more miles have been affected since then. The study also estimated that past and future mining could destroy more than 1.4 million acres of forested mountains and threaten 240 animal and plant species. With the growth of human civilization over the past few thousands of years, half the world's original forests have disappeared. Accounting for forest replanting, we lose forest land the size of Iowa every 2 years. Over half are lost due to the pressure of growing populations in poorer countries, where slash-and-burn techniques are used to expand croplands. More than 25% of our CO2 emissions come from slash-and-burn forest clearing, and half of the wood harvested worldwide is used for fuel by the world's poor. In contrast, developed countries, including the U.S., are actually expanding their forest, simply because we can afford to burn fossil fuels instead of wood. Many experts estimate that we might be able to stabilize Earth's climate if we can keep CO2 levels no higher than 350 parts per million. As this chart shows, the 350 threshold was crossed in 1985, and we've increased by about 2 parts per million per year over the last decade, with the current reading of 393.69 as of June 2011. The last time CO2 levels were this high was 15 million years ago. This quote is from a UCLA report. The last time carbon dioxide levels were apparently as high as they are today and were sustained at those levels, global temperatures were 5 to 10 degrees Fahrenheit higher, the sea level was approximately 75 to 120 feet higher, there was no permanent sea ice cap in the Arctic, and very little ice on Antarctica and Greenland. Humans as a species have only been around about 200,000 years, and we only left our hunter-gatherer past about 8,000 years ago. As a species, we'll be greatly testing our much-vaunted smarts to either A, endure the shorter-term pain of lowering our greenhouse emissions now, or B, enduring a long-term pain of adapting under duress to conditions on a much less hospitable planet. Experts also believe we are on track to reach 450 parts per million, which represents a tipping point, when increased global warmth will lead to more global warming caused by melting of the Arctic tundra and Arctic ocean bed methane, an even stronger heat-trapping gas. The insert shows a waterfowl that apparently ingested various human items, mostly plastics. Numerous worldwide waterways are contaminated with human waste and debris, including plastic items and toxic chemicals. A June 2011 report from the International Program on the State of the Oceans claims that the oceans are under siege by a deadly trio of threats: rising water temperature, acidification, and lack of oxygen, that played a role in similar mass extinctions 55 million years ago. According to the report, this time humans are largely to blame. Overfishing alone has pushed many species to the brink of extinction. Pollution and runoff of fertilizers from farms have choked out life in vast areas, creating dead zones. And the oceans absorb most of the carbon dioxide we pump into the atmosphere, changing pH or acidity levels and adding stress on all kinds of marine creatures. Perhaps the greatest harm we humans have inflicted on nature is our unintentional damage to thousands of plant and animal species. Here we see a few that are threatened and may well be extinct within this century. Some experts claim we are now experiencing the sixth extinction, and most scientists believe the rate of loss is greater now than at any time in the history of the Earth. Within the next 30 years, as many as half of all species could die in one of the fastest mass extinctions in the planet's 4.5 billion years history. Every day, an estimated 100 plant and animal species are lost to deforestation. A conservative estimate indicates that about 27,000 species a year are being lost. Fossil fuels have allowed us to feed increasing numbers of people, with use of natural gas for fertilizers, pesticides, and herbicides, and petroleum for planting, harvesting, processing, and transporting. We've more than doubled our population in the last 50 years, and the amount of farmland per person has halved. As fossil fuels deplete, topsoil erodes and degrades, and water aquifers are overpumped, it will become increasingly difficult to feed a human population of 7 billion and growing. The current famine in Somalia and Ethiopia are signs of food crises that will only worsen with increasing population growth. We've now touched on the major converging environmental crises, but here's a recap. Water, the most essential resource for life, is threatened with declining aquifers, polluted waterways, shrinking mountain glaciers, rising sea levels, and acidifying oceans. Our air is increasingly affected by pollution, high CO2 levels, higher temps and humidity in places, and erratic currents. Arable land is being degraded with topsoil loss, deforestation and desertification, and mineral and fossil energy extraction. Food sources are affected by declining fisheries, loss of arable land, water shortages, expensive meat sources, and population growth. In addition to the crises associated with climate change, depletion of fossil fuels and minerals, and extinctions of wildlife and plant species, one crisis we've not emphasized is the worldwide social and political instability. In the U.S., we have the Tea Party and the Occupy movements, and there are various uprisings around the world, including in Arab-speaking countries. Increasingly, we are experiencing a number of failed states, with refugees seeking food, shelter, and safety. Finally, if we fail to point out the worldwide population growth, here is a quick summary. 9,000 per hour, 200,000 per day, and 70 million annually. That's net gain, births minus deaths. In sum, we're adding the equivalent of 2 Californias or 2 Canadas per year to the world's population. At least 5 billion of our planet's 7 billion are poor and need to consume more in order to improve their quality of life. But the richer 2 billion show no signs of voluntarily using less of Earth's resources. Our finite planet cannot long support the seemingly infinite needs and wants of a single species.